In this presentation, we're going to look at sequences and series, and in particular, what we're going to do is look at some arithmetic progressions and series and so on. So what we're going to do is find the sum of the arithmetic progression 11, 13, 15, 11 plus 13 plus 15, then they're all the way up to 49 and 52. And what we have here is a series, like some terms that have been excluded from the written expression just because we should be able to figure out what they are. But I haven't actually I have actually specifically said it's an arithmetic progression. But let's just say, for argument's sake, I didn't exactly tell you that, and it was just some series. Well, what we're going to do first off is just check the adjacent differences, the difference between one term and the next. Here it's 2, here it's 2, and so on, and here it's 2. So you could say pretty clearly that the adjacent difference between each term is 2. So we're going to write that down as d is equal to 2. My pen is a bit strange here anyway. So moving on from that, that's just one thing to pick up on, that there's a sort of constant value that is the adjacent difference between each pair of adjacent terms. Now, first recall two useful equations for working with arithmetic progressions. For the arithmetic sequence a plus d, a plus 2d, and so on, never mind that, pardon me, what we have here, Tn is the nth term of the series, okay, and I'm dealing with series here right now, so I just said series, and it is a plus n minus 1 times d, okay, and the sum of the first n terms is given as follows. The expression here at the bottom, I think it's just cropped out of screen, so I'll just move it up there a little bit. Oops, there we go. So it's a bit clearer to see there. So S of n, that's the sum of the first n terms, is n over 2 times 2a plus n minus 1d. So the expression we were just dealing with there previously, we have to find out what a is, we have to find out what n is, and we have to find out what d is. Well, actually, we found out what d is already, so we don't have to worry too much about that. So d was 2. Now let's just look up here again. If you recall, the first term there was a plus d, and a plus 2d. So those are the first two terms. So if you just look back here, we'll find that the first term there is 11. So a is equal to 11. And the last term here is 51. Okay, so this is the nth, the very last term. So we have to find out what number term, which number in the series it is, or which value is the first, second, third, fourth, fifth, or so on. So we have to find out what that is. So we note that a is equal to 11 and d is equal to 2, and we want to find out what n is, and the last term there is 51. So that's just everything I sort of remarked upon there just a second ago. And what we're going to do is actually use the fact that the last term is 51, and using that formula there, I used the first of the formulas there I mentioned previously. T of n, we're going to let that equal to 51, and that is equal to 11 plus n minus 1 times 2. Okay, so if we simplify 11 plus n minus 1 times 2, we have, make this pen a bit smaller here, we have 11 plus 2n minus 2, and that works out to be 2n plus 9. So 51 is equal to 2n plus 9. That means 2 of n is equal to 51 minus 9, and that's equal to 42. And therefore, that n is equal to 21. So there are 21 terms in the series. Okay, so that's going to help us now. So we know n is 21. We know A is 11. The first term A is 11. And we know that the constant difference D is 2. So we should be able to piece all that together now and find out what the sum of n is, S of n. So that's the expression there again. S of n equals n divided by 2. So let's do that. That's 21 over 2. Now that will work out to be 10.5. Don't worry about that. 2 times A is 22. N minus 1 is 20 times 2. D is 2. So that's 10.5 by 22 plus 40. And that it works out to be 10.5 times 62. Now it's just a little bit of calculator work actually. It's 10.5 times 62. And in that case, all we have to do is just a little bit of calculator works and get our answer. So we're almost finished. So the answer is 10 times 5, 10.5 times 62, and therefore our answer just works out to be 651. So that's it done. That's our answer, and we're going to leave it there.